Hey, Miss Weatherall here. I am going to go over to this week's lesson, which is the 45, 45, 90 triangle. We're going to focus on that. There are two special right triangles we're going to talk about over the next 2 weeks. So you should be able to develop properties of the special right triangles, and by that I mean the ratios. And you're going to be able to solve for the unknown side of a triangle. And then what we did a couple weeks ago, we're going to rationalize the denominator. I love to do that. Doesn't that sound so much fun? All right, so here we go. This is basis and how they come up with the 45, 45, 90 degree triangle. You're looking at a square with 1 inch units all around it. So if we take that 1 inch and we put a diagonal line through it, we can see that it forms two triangles. And it forms two 45, 45, 90 triangles because a square, the right angles are here, cutting it in half makes each angle that it cuts in half 45 degrees. So with that being said, how can we find what this missing side here is, the diagonal? Well, we use the Pythagorean theorem. So let's just say we're going to use this triangle here that I'm shading in red right now. We know that each side is 1, so we're going to take 1 squared plus 1 squared and set it equal to c squared. Doing the math, 1 squared plus 1 squared is 1 plus 1, you get 2. So how do you get rid of the square root? If you remember, the square, you take the square root. We talked about that before school is out. And if you take the square root, you also have to take the square root of the other side. Notice that it is not plus or minus because you cannot have a minus measurement for that hypotenuse. So how getting that side, the radical 2, that's how we come up with it. But we can take a shortcut if we know the 45, 45, 90 ratio, which is each of the leg of the triangle. Now remember, this is a right angle and this is your hypotenuse. So the number ones that I'm circling are your legs. So this is a leg of the triangle and they are the same measurement. They both equal 1. And if it's a 45, 45, 90, no matter what side, if this your measurement is, it's going to also be the same for your other leg. So no matter what number this one is, it is also going to be the same for the other leg. So if this was a 10, this would have to be a 10 down here. I hope that made sense. And then the ratio of the hypotenuse is radical 2. So if we're going to put that in algebraic terms, we can say that each of the legs, now we know that these sides are congruent, are x. And the hypotenuse is x times radical 2. Okay, so it sounds confusing, but watch these examples. I think you're going to pick up really quickly. So what you need to memorize is the x, and a x radical 2 for a 45, 45, 90 triangle. So looking here, I'm going to have my base triangle here. I just put it in red. So this is my reference, and I call it my base triangle because this is what I refer to, my reference triangle. So this is my base triangle for a 45, 45, 90 triangle. So looking at this base, I can see that here in the same position is a 4. Well, right here, my other leg, I know has to be a 4 because the x's are the same. And how do I find what is missing? You multiply by, well, what's that number right there? Radical 2. So you take 4 times radical 2. That cannot be simplified any further, so those are your legs are 4, and your hypotenuse is 4 radical 2. Did not have to do Pythagorean theorem, did any of that. The shortcut will help you. So let's do another example. And again, as always, I start off easy and I get a little bit more difficult as we go. So I've got my base triangle. I'll put it in red again for you. I have a leg of 9. So before I tell you, you should be able to tell me what the other leg down here should be. So you should have said it's the same and it's 9. And so I've got my x's and x's. How do I find my hypotenuse? I take x and I multiply it by radical 2. So my x is 9 in this case. So 9 times radical 2 is 9 radical 2. That's it. You're done. So looking at another example, again, I'm trying to get this pattern in your head so you understand that pattern. If I'm given one leg, that's in the same position as my x. You should be able to tell me what that other leg is automatically. And hopefully you said it's 2 because x equals x. It's the same. How do I go from my leg to my hypotenuse? My hypotenuse is x radical 2. So I multiply the 2 by my radical, and I get 2 radical 2. Easy, right? Sure it is, but let's let a little bit more challenging numbers. Not really too difficult, but a little more challenging. So my x in this position, again, there's my base triangle in red, is radical 7. That is still my x. So you should be able to tell me that the other side, the other leg of this triangle, is also radical 7, or rad 7. I'm going to maybe take a shortcut and say rad instead of radical. So then what would I do to get to my hypotenuse? Well, according to this, I'm going to take my x and multiply it by radical 2. So that's what I'm going to do. I'm going to take my rad 7, multiply it by rad 2, because x rad 2, rad 7 is your x times rad 7 is your x times rad 2. You get radical 14. Now, I look at that 14 and I ask myself, your favorite thing to do again, can 14 be simplified? Is there a perfect square that goes into 14? The answer is nope. So your answer is radical 14. So rad 7 for each of the legs, hypotenuse rad 14. It's fun so far, right? So let's try again. And if I'm going too fast, you can rewatch this video. You can back up. So now let's go backwards. I got it all squished in there, but that's what it says. Let's go backward. So now, instead of starting with the leg, they're going to start with the hypotenuse. And remember, you can always find the hypotenuse by taking an arrow straight through your 90-degree angle there. That is always going to be your hypotenuse. So that is a position 3 radical 2. So what am I going to do to get here? Well, if I've got x radical 2, in order to get rid of my radical 2, I'm going to have to divide by radical 2, right? So doing that, how does that play out? This is where you're going to divide by radical 2, and this is where we're going to have to rationalize our denominator. So our hypotenuse was 3 radical 2, and we know that we have to divide by a radical 2 to get our leg. Well, in this case, it's pretty easy. The radical 2's cancel out. So I know that my leg has to be 3. So each of your legs are 3, because remember, if this is x, the other side's x, so that's the same. So they're 3. So that's the answer for that example. Again, I'm going to start easy, and then we're going to get a little bit more difficult. So 6 radical 2. Okay, that's in the position of your hypotenuse. So before I tell you, what do you do when you just need an x, when you got an x radical 2? How do you get rid of that radical 2? And I heard somebody say, not really, but you know, I got imaginary friends, so anyway, you divide by radical 2. So doing that, guess what cancels out? Your radical 2's. So you're just left with 6. So in this particular case, you have a hypotenuse of 6 radical 2. You divide by radical 2 and you're left with 6. Okay, so if this is x is 6, well, what's this x got to be? Has to be the same. So that is also 6. So hopefully you're picking up on the pattern. But let's try, well, this one's easy. I'm just going to go over this one real quick. 11 radical 2, I divide by radical 2. What cancels out? You got it, the radical 2's. So each side is just 11. Okay. So enough of the easy stuff. Let's do a little bit harder. Now I know I went through that quick because it was more of an example that I already did, but you can go back and watch the video. So now I'm given radical 8 as my hypotenuse. So that's my x radical 2. How do I get my x? So I've got x radical 2 and I need to just x. So in order, I need to cancel out my radical 2. So again, I'm still going to divide by radical 2. So I've got my hypotenuse, which is 8. I divide by radical 2. This is where our skill of rationalizing the denominator comes in. I'm just going to abbreviate that. So how do I get rid of a radical in the denominator? You take that radical and multiply it by itself. What you do to the bottom, you have to do to the top. So radical 2 over radical 2. Now multiply straight across. So 8 times radical 2 is 8 rad 2. Radical 2 times radical 2. Now remember, that's the rad 4, the square root of 4. The square root of 4 is 2. So the shortcut, if you take a radical, any number inside the radical or your radicand, and you multiply it by the same, it cancels out. It's like squaring it is what it's doing. So they cancel each other out. So you're just left with the radicand. So if you remember that shortcut, you can just go straight to the 2. Otherwise, go ahead and do the math. Radical 4, and the square root of 4 is 2. You're going to get it either way. So now look at this answer here. I don't have an eraser, so we're going to look at that there in my little rectangle there. Look at the numbers outside the rad. Can they be reduced? Well, yes. 8 divided by 2 works out evenly, so your final answer is 4 radical 2. So go through this process again if you need to. If you need me, you can email me and we'll talk about it. So going from 8, we divided by radical 2. We just did the math, and we said we got 4 radical 2. Well, that's my x up here in my base triangle. So what does the other side have to be? You got it, 4 radical 2, because they have to be the same. So that's a 45, 45, 90 property. So let's do another example where it doesn't work out so pretty. I've got my 4 as my hypotenuse, which is my x rad 2. So in order to go down to my leg, I am going to divide by radical 2. So here's the math. I take 4 and I divide it by radical 2. We do not like a radical in the denominator. That's a no-no. You like my no-no? Anyway, so in order to get rid of it, I have to multiply it by itself. So radical 2, what I do to the bottom, I do to the top. Multiply straight across, you get 4 radical 2 for your numerator. Rad 2 times rad 2 is rad 4. Or if I know the shortcut, the square roots are canceling each other out, so I'm just left with 2 either way. So now look at your answer, 4 rad 2 over 2. Look at the numbers outside your radical. Can 4 be divided by 2? The answer is yes, 2 radical 2. So that is your leg. So 4 divided by radical 2 gives you 2 radical 2. So if that's one leg, what's the other leg got to be? Got an x, so the other one has to be the same, 2 radical 2. So I think this is the last one. So you're saying yay, but I'm saying no, because I love math. All right, so you tell me. I'm going to this one. I'm going to slow down just a little minute, try to get you through the thought process. So I'm identifying this triangle as a 45, 45, 90 triangle. That's the first thing I do. I remember my base triangle, whether I sketch it down on a piece of paper and have it in front of me, whether I have a screenshot and have it in front of me. But my base triangle for the 45, 45, 90, I have a reference. I know that both of the legs are going to be x. And I know my hypotenuse is whatever x is, and I'm going to add a radical 2. But I'm starting with the x radical 2, so this is my x radical 2. I need to go down to my x. So I'm going to go down to my x. How do I get x by itself? If I'm multiplying, you divide by radical 2. And then go through that process. So on this screen here, we take 6 and we divide it by radical 2. We do not like, again, that's a no-no, no rads in the denominator. So how do you get rid of it? You multiply it by a radical 2. What you do to the bottom, you do to the top, multiply straight across. Look at your answer, see if your outside numbers will reduce at all. And you know that 6 divided by 2 is 3, and you're left with a radical 2, which is really over 1, but you know that anything over 1 is that. So you get 6 as a hypotenuse goes down to 3 radical 2 for your leg, and your other leg has to be the same, so you know that that is also 3 rad 2. So really there's only one step you have to understand. You're either multiplying by radical 2 or you're dividing by radical 2. So now you need to memorize, this is all we're doing this week, because I need you to memorize this lovely triangle. It will come in handy next year in Math 3 as well. So memorize the triangle 45, 45, 90. It'll also come in handy when we start trig in 2 more weeks. Love trigonometry. But anyway, 45, 45, 90, the only thing I would add would be that little box to know that that's a 90. But x for the legs, x radical 2. Memorize this. Did you get the hint? I want you to memorize that. So now we're going to practice using the ratio. It's the only way that you're going to get a good understanding of this. If you do two problems, you're not going to get a good understanding of it. So please do some practice problems. I'm going to give you more graded ones because I need you to make sure that you're practicing. Because even though I trust you that you're doing everything I ask the practice problems, I am not confident you're really doing them. So anyway, that's what we're going to do. So practice, look at the answer key, then that's when you email me and say, hey, Miss Weatherall, I didn't get this right. I don't understand why. Take a photo, send it to me. I'll tell you how we can correct it. So have fun. I miss seeing you. I hope you all are well.